you want to say hi, say hi.
Uh,
There you go. You're on YouTube now. Okay.
views.
All right, guys, ready?
You know the ad.
Here's the deal. You have to be patient with me because I made these notes in July. And then I kept making them. And as time went on, I got better and better. In the very beginning, I wasn't quite seeing it. And so you'll see some slides up here. You'll go, that doesn't look like my slide because I took things off or I added things in. So you need to add some things in once in a while. Okay. Here we go. The numbers today that you talk about, they're called the real numbers. It says the numbers you use in everyday life are called real numbers. Okay? They are classified into different categories as shown below. So the whole group of numbers we talk about are called the real numbers. Every number you can think of is a real number. What's the smallest group of numbers? Looking up there. Natural, yeah, it's natural, right here. This is the smallest group of numbers. Those numbers are just what? 1, 2, 3, 4, 5, known as your counting numbers. So this is what is a little bit new. I did not put this in your notes. Next year's students will get this. Okay, so what are the natural numbers? I'm going to ask you to write them down because if you write them down, you will remember better, I promise. So basically 1, 2, 3, 4, 5, 6, 7, forever. Forever. Okay, then we make that group a little bigger. How much bigger? Not much. This next group is basically the natural numbers and what else? And what else? 0. You just add one more number to the natural numbers. Now we call it the what numbers? Whole numbers. So the whole numbers are a little bigger than the natural numbers. Not by much. Only one number. That one number is 0. So whole numbers don't get much bigger than natural numbers. You just add another number in, it's called 0. Okay, let's get bigger than the whole numbers. Let's add more numbers in. What about this next group called the integers? The integers are going to be the naturals and the whole number. And what else? All the negatives. So now the negatives come into the picture. So to me, integers are negative infinity all the way up to positive infinity. So I'm going to write it like this, just so you know, these are the integers. Okay, there you go. Okay, so there's the integers. Then they get bigger than the integers. They go, there's more numbers out there. What about these numbers? They're called the what? The rational numbers. Now, how did this make the group bigger? Okay, so in other words, you're getting in between numbers. So like if you want to get in between 2 and 3, guys, how do you get in between 2 and 3? Give me a number. 2.5. 2 1/4, 2.9, 2.7. That is in between 2 and 3. So this group gets even bigger. So what does this group add? This group adds in what? All the fractions. Okay. Or better yet, you can just turn fractions into what? Decimals. Okay. So the rational numbers bring in the decimals and they bring in the fractions, right? Okay. But there's a little trick here. The trick is right here. When you talk about decimals, it's a certain kind of decimal. What kind? Decimals that do what? Repeat. If a decimal repeats, it's rational. Okay, help me out, guys. 2/3 is a fraction, so it's rational. But does that fraction repeat if you turn it into a decimal? Did you guys bring your calculator today? Yeah? Guess what? You might want maybe one per group. Just take one. You guys have it? Okay. One per group. You guys have it? You guys need one? Okay, you guys share that if you could. You guys have one? Yeah? Okay. You guys have one? Okay. Share it if you can. You guys have one? Okay. Okay, you have one? Two girls?
A little bit.
if anybody wants it. One. Going once, going twice, going 3 times. So, it's right there. Okay. Tell me, point, 2/3 is what?
6 repeating.
Point what?
6 repeating.
6. Okay. So, if you see a fraction, it's obviously a rational number. But, decimal-wise, 0.6 repeating, oh, it's a rational number. Okay. Where does this one repeat? That's called 0.3. What comes after the 3?
3.
No, not 3 because there's not. If there was a bar on top, I'd agree with you. So what comes after the 3? Yeah, this is called a terminating decimal. It stops. If a decimal stops, after the last digit is a bunch of what? Zeros. Guess what? It repeats. It's rational. It's rational because it repeats. Where's the repeating going on here? After the 5. That is a decimal that terminates. It stops. That is the end of the number. But what's behind the 5? Zeros. Why don't we write zeros?
Because you just know.
Well, there's no reason to write a 0 because a zero actually means what? Nothing. It means nothing comes after the 5. Why would I write zeros? It'd be a waste of my time. But there are a bunch of zeros, and because it repeats, we call it rational. Okay, next. If it's not rational, then it's what? Irrational. Oh, like what? Pi is irrational. Okay, is pi a decimal that repeats? Type it in. What is it? 3.1415 what? 9. Okay, does it stop at 9?
No.
No, it keeps going. Is there any repeating going on, like 141414? 14159, 14159. Does it keep repeating? No. Guys, it's just random numbers, never repeats. And because, here I'm going to write this, decimals, and I'm going to write decimals followed by what? Oops. What about the decimals? They never what? Repeat. That's how you know it's irrational. They never repeat. Oh, what about the square root of 2? Is the square root of 2 a decimal that repeats or never repeats? Okay, what is it, Dallas?
1.4142, whatever.
Okay, 1.41 what? 2. Give me a couple more. 135, blah, blah, blah. Okay, do you guys see any repeating going on here? No, it's what? It's irrational. Okay, so what is irrational? Decimals that what? Never repeat. What's rational? Decimals that what? Repeat. But if you see a fraction, if you ever see a fraction, it's rational. Okay? Because all fractions can be turned into decimals. Okay? All right, I think I've got a couple more down here. I think you want to write this down just to get an idea. What are rational numbers again? Let's just say it again. They're what? Good. They're fractions / decimals that what? Yeah, that repeat. Okay. Bingo. Okay, but if we talk about the irrational, they would be the, if these are fractions, these are what? Non-fractions. They can't be written as a fraction. And they're also going to be decimals that what? They don't repeat. Never repeat. Bingo. Okay? Your job today is to look at a number and say, that is rational, that is whole, that is natural. Okay? Now, here I got a question for you. What about this one? Where does this fit? Where does the square root of 9 fit? First of all, what is the square root of 9? It is 3. Okay. Okay. So, what comes after the 3? 0, 0, 0, 0, 0. Okay, it's repeating. Is it rational?
Yes.
If it repeats, it just repeats, then it's rational. Square root of 9, it belongs in this group, right? Okay, you guys know the square root of 9 is 3. Is 3 an integer?
Well, yes, but it's in that number.
But no, I'm going backwards. I'm gonna get down there eventually. If square root of 9 is 3 in this group? What are the integers? -3, -2, -1, 0, 1, 2, 3. Oh, guess what? Square root of 9 is 3. It's in the integers. Square root of 9 belongs in here. Is the square root of 9 in the whole numbers? Yeah, because it's 0 on up. Square root of 9 belongs in here. Does square root of 9 belong in here? Yeah. Square root of 9 belongs here, 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 everywhere, except here. Why doesn't it belong there? Because it repeats. And if it was irrational, it would never repeat. Here's the deal. Let's just practice. Here's your, oh, I'm sorry, I thought we had a practice problem. Here's a quick comment here. It says real numbers, for instance, that group called the integers can be divided into 3 categories. Integers can be negative. Integers can be what? Positives. And what's that again? 0. 0 is not positive or negative, but basically they're telling you the integers are the positives, the negatives, and 0. Okay. All right. This is your actual first problem. And this is what your assignment starts out with. Which of the numbers in the set, right here, are natural, integers, rational numbers, irrational numbers? Okay? I'd start right here. Start with the smallest group there are. Do you guys even know your natural numbers? What are the naturals?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Okay. Start looking. Is 0 going to be in this group? No. Just 5, right. Just 5 is in the natural. That's it. All the rest of them are negative, 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 fraction. 0 is not in the naturals. Square root of 2, okay. All right, integers.
-7.
Okay, -7 is an integer. Yep.
-1.
Yep.
0.
0 is an integer. Yep. 5. Oh, look at that. So look what 5 did. 5 was a natural. But 5 goes into the integers. Now, if something's natural, isn't 5 going to just be in all these groups? Well, except for that one, because that's a different kind of number. All right, next. Rational. What's rational? Anything that can be written as a fraction. But it's also going to be the naturals, the wholes, and the integers. So what's rational? 3 what? 3/4 is rational because it's a fraction, yeah. -1/5 because it's a fraction, yeah. Hey guys, you see these integers? You looking at these integers? Are these fractions? If I put them over 1, are they fractions? Yeah. So guys, if something's an integer, integers fit inside the rationals. So if you see integers, they're all rational. You just copy those down, don't you? Right? Can you tell me what is a rational number? It's a number that it repeats. Hey guys, does this repeat? 5? Does 5 repeat? Point what? I mean, I'm not going to do that, but it repeats. Does -7 repeat? There's the decimal. Isn't it just a bunch of zeros afterwards? Yeah. There's repeating going on. I don't write that down. I don't expect you to write it down. Okay? All right. Next. Okay. If you say something's rational, then whatever you haven't talked about must be what? Irrational. What haven't we talked about? There 5. Yep. -square root of 3. Yep. And -square root of 2. Got it. These are irrational because these are all decimals that repeat or don't repeat. They don't repeat. Don't trust me? Type it in. Okay? I Are you okay? This is something you might have done in Algebra 1. I don't even know if you did. Okay, then they start talking about the real number line. Okay, I'm going to paraphrase a little bit. You are staring at the real number line. It's just a line, and right where you see the number 0, they call that the what? They call that the origin. The origin to me is, where do I start? I start at 0. To the right of 0 are called what? Positives. To the left of 0 are called what? Negatives. 0 itself, is that positive or negative? It's what? It's neither. It's called neutral. 0, you don't put positive 0, you don't put negative 0. 0 is neutral. But to the right is positive, and to the left is negative. That's it. And if you read all that stuff I just said, that's what they told you right there. Okay? 0, and then it says right here, 0 is neither positive nor negative. Okay? All right. Now, this is a comment down here that you need to kind of understand. The book will talk like this, and you need to know what the book is saying. So let me read this to you. You can use the term non-negative real numbers. If the book ever says non-negative real numbers, what are they talking about? Non-negative means it can't be negative, so it's got to be what? It's got to be positive, okay? Oh, good job. If something's non-negative, it's not negative. It must be positive. But it also could be what number? 0 also. So if the book starts saying things like, use only non-negative numbers, non-negative just means, oh, I get to use 0 and all the positives. Kind of weird, but that's just something they taught. Okay? All right. Here's your number line. It's down there. It says this. Each point on the real number line corresponds to exactly one real number. Okay? Watch this. Boom. There's my 0. Okay? Each point, okay, there's a point, on the real number line corresponds to exactly one real number. What's that point? Who can tell me the answer to that point? 1. The answer is 1. So if I put a point on a number line, you look below it and you say, oh, that point is 1. And each real number corresponds to exactly one point on the real number line. So if I said plot the number 3. How do you plot 3? You look for 3 and you do what? You put a point. There. That's all that said. Each number gets a point. Each point gets a number. That's really all they said. Now, when you draw the point on a real number line that corresponds to a real number, you are doing what? Plotting. Your book's going to say plot the point. Well, plotting just means plot. Give me a point for that. Give me a point for that. Put some intervals down and show me what you're going to do. I'd always put the origin down first. Put 0 down. I'll just put some numbers down. I don't put a lot of numbers down. I just put maybe 0 and a 5 and a negative 5. Okay? You plotted negative 3 where? Just say, from 0 I went which way? Left, how far? 3. Okay, there you go. Negative 3, got it. That's this one. Okay, and then 5, how'd you plot it? To the right is 0. To the right, I always say, to the right is 0, how far? 5, there it is. You just plotted negative 3 and 5. That was easy, right? Okay, is it always that easy? Okay, let's keep going. There's your next problem. Graph 9/4, 2.3, negative 5/3, and negative 0.3. This will be a little harder for you. Put your intervals down. I put 0 right in the middle. Might want your calculator on this. Get started. 9/4. What about 9/4? How did you change that? Or were you able to visualize 9/4? What that says is 9 divided by 4. How many times does 4 go into 9? It doesn't go into 9 evenly.
125.
It goes in there twice, right? With a remainder of what? What's the remainder? 1. You have a remainder of 1, and then of course you're dividing by 4. So really it's 2 1/4. Or better yet, some of you probably went into decimal, right? 2 point what? 2.5. Oops, I put an approximation. I meant what? Exactly. Okay. To me, to graph 2.25 is pretty easy. I go 2 1/4 more. So there's your 9/4. Okay, 2.3 though. Where's 2.3? Well, 2.3 is really 2.3. What comes after the 3? 0. So that's like saying $2.25, $2.30. Where will the 2.3 go? Yeah, right next to it, but what side? Further to the right or to the left? To the what? To the right. You'd probably put a 2.3 right there, wouldn't you? Okay, there's your 2.3. And negative 5/3 is on the negative side, but what are you going to do here? Change it to what? Fraction or decimal. What is it? Negative 1 and what? Oh, you did 0.6 repeating. Anybody do this one? Negative 1, remainder 2/3. If you did that, same thing. Okay, here we go. Negative 1 is here, negative 2 is here. Well, if you're 0.6, you're a little closer to 2. Okay, so there's your negative 5/3. Okay. What about the negative 0.3 though? You'd be closer to 0. You'd be like, yeah, here. There you go. And that's like saying I lost 30 cents. This one's like saying I lost $1.60 what? 6, right? And there you go. That's kind of why it got harder. It got harder because you had decimals and fractions. Okay. Okay. Here's the again the real number line and not only that, but we're going to do what? We're going to use order, and order talks more about this greater than or less than. Okay. Okay. So let me just do this quick. I'm going to put a 0 there. 1, 2, 3, 4, 5, 6. I'm going to go like this, and then I'm going to go like this. Okay. So I put 2 numbers down for you. I put negative 3, and I put down 2. Okay. Can you tell me right now, if I'm comparing negative 3 to 2, what symbol would I use? Negative 3, compare it to 2. Is negative 3 less than or greater than 2? What is it? Less than? Okay. So I'm hearing this. Negative 3 is less than 2. Everybody agree? Why did you say less than? Because it's what? A negative number is always smaller than a positive number. Okay, that's good. But look at the number line. Where did negative 3 fall compared to 2? On the left or on the right? Yeah. The smaller number falls where? On the left. The bigger number falls where? On the right. That's true all the time. Okay, so what if I went like this? What if I said 2 compares to negative 3? How would you write it now? Yeah, this is on the right, this is on the left. 2 is going to be greater than negative 3. Do you guys struggle with greater than, less than? Some students do though, some students do. So watch this. Always remember, if you make a Pac-Man out of the deal, Pac-Man always eats what? The bigger number, right? So whatever you do, look at it and say, if 2 is bigger, make sure it opens up to the 2. Or better yet, it always points at the what? It always points at the smaller number. Negative 3 is smaller. Hey, negative 3 is smaller. I mean, that might help you too. This down here is talking more algebra-like. I just want to say something. I'm going to use these numbers instead, okay? You know, here it says, if the real number line A lies to the left of the real number B, so instead of saying A, which one falls left? -3. I'm just using those numbers instead of A and B. If the real number -3 lies to the left of the real number 2 on the real number line, then A is less than B. I'm not going to say A is less than B. I'm going to say what? Yeah, -3 is less than 2. That's what this is saying to you. And by the way, is this even on here?
Yeah.
It's on there. Okay. I get a little nervous talking to you about A's and B's and all that. I feel like I might be losing you. So I like to throw numbers in so it makes more sense to you. I hope that makes sense. Okay. Down here they talk about less than or greater than and equal. So do you guys understand that is what? Remember, if I had I'd have to have something like this, wouldn't I? 6 is greater than or what? Equal. These are called inequalities. So whenever you hear inequalities, that's what I'm talking about. Okay? Okay, all right. Go ahead. Do some magical less than greater than symbols. Okay? The number line is going to really help you. I can tell you that. You will get some numbers that are kind of confusing to you. -4 and 0. Look at my number line. I just told you that if a point falls to the left of another point, which one's smaller? The one on the left is smaller. The one on the right is bigger, right? So -4 compared to 0 is what? Smaller or bigger? 0 is bigger, but they started with -4. -4 is what? Smaller or bigger? Smaller. And because it's smaller, it points at the smaller number. Remember? Pac-Man eats the bigger number. 0 is bigger than -4. Okay? Move on. Look at -3, look at -5. Okay, here's -3, here's -5. Okay, they're both negative. But which one's bigger? Tell me the bigger one. The bigger one is always what falls on the right. The smaller one is on the left. So you'd say -3 is bigger than -5, but they started with -3. -3 is what? It's bigger, it better, Pac-Man better eat the bigger number. I don't know why, but this gets really confusing to students. Just because of which way the sign points. Okay, 1/5, 1/3. This is a little more difficult, right? 1/5 as a decimal is what? Uh-oh, not talking. 1/5 as a decimal. 0.2. 1/3 as a decimal. It's not 0.3. It's actually 333, right? Okay. So if I were you guys, I would put a 0 behind the 2, and I put a couple 3s. That way you can think of money. 20 cents versus 33 cents. So where is 1/5? 1/5 would be smaller than 1/3. 1/3 would be a little bigger than you. So right now you can already tell, can you? Which one's bigger? 1/3. So 1/3 is the bigger number. Make sure you open up to the bigger. 1/5 is less than 1/3. Last one. Which way did you go? Just curious. Is -1/4 greater or less than? You went with less than. Okay, let's check it out. Ready? On a number line, here's 0, here's -1. -1/2 would be halfway, right here. -1/4 would be a quarter of the way, right here. Okay, look at the number line. Which one's farther right? Part of the right would be this one. This one's bigger or smaller? Bigger. If it falls to the right, it's bigger. If it falls to the left, it's smaller. So, negative 1/4 is bigger than negative 1/2. We have this wrong. Should be this way, shouldn't it? Right? Number line helps. It just does. All right, check that one out. I think I changed the 5 to positive on you. Is that right? No, I changed it to positive, right?
On that one.
It looks negative on yours. Get rid of it. Just call it 5. Find the distance between 5 and 10. This should be really easy for you. What is it? Distance between here and here? 5. Okay, how did you get it? You just added 5 and 5 and get to 10. Okay. What if it was a lot harder than that? Then you subtract, don't you? What do you subtract?
Bigger number.
Big. Oh, good job. It's bigger number minus what? Smaller. So it's big minus what? Small. And that is how you find the distance. It's always big minus small. Now down here, guys, that's what they're telling you. If 10 and 5 are two real numbers such that, I said that wrong, since 5 and 10. If 5 and 10 are two real numbers such that 5 is less than 10, then the distance between A and B is given by this formula right there, B minus A, which would be 10 minus 5. Okay? Find the distance between these numbers. It's always big minus small. Big minus small. What do you do with a double negative? Double negatives, what do? Don't we change them to positive?
Yes.
Okay. Answer's what? 5. That's the work you need to show. What's the big here? 4 minus the small is 0. Answer is 4. Which one's big on this one? 0 is actually the big. Minus the small is what? Negative 4. But minus makes what? Plus. Answer? 4. Which one's big? 1 is the big. Minus the small. Change it to plus. The answer is what? 1.5. Okay. The distance between two numbers is pretty simple. It's just subtraction. Is what it is. Take big 2.5. If you have $1 plus $0.50.
Oh, I read it wrong.
Oh, did you? Oh, you read it as 1.5. Yeah. Okay. That's the assignment in your book today. It's the next slide. Just look at the next slide. It's there. It's there. It tells you the assignment, doesn't it?
Yeah.
Okay. Pages 2 through 8. You gotta look at it. You gotta keep the book. Yeah. Just until May 30th. Then you can give it back.
I got it.
Come May 30th, I'll take it back. Yeah, serious. Yeah, May 30th.
Oh, hold on, okay.
Did I ask your class this? Is there anybody in here that would rather not have a book and just do this? Take your phone and take a picture of the pages? Because I'm going to have more students joining our class, and I don't have any more books. But that picture thing takes time. Okay. I mean,
Drop that in the
that's
second
something
I have
class.
2 math, so I have very math.
Your geometry and
I have to redo my first semester of geometry. Last year I skipped a lot. Alex, stop.
So you might be interested in something like that?
Yeah.
As of right now, I don't need you to do that, but I'm gonna. I'm trying to call the company and see if I can get more books.
Unless you got next grade.
And these studies.
I was gonna make it.
Oh,
Two and a newborn, so.
you have so how many kids do you have?
I haven't gotten a list of fourth or first and fourth.